It's a daunting task to talk about the climate science in 15 minutes. And I was also asked to talk a little bit about role of the ocean and ocean acidification, and it's not possible. If I had 15 hours, maybe. But anyway, it's going to go really fast through these slides, and you can get a copy of the slides. And I made two other smaller PowerPoints, one on role of the ocean and climate change, conveyor belt, and where the heat is going, where the CO2 is going, and another one on ocean acidification. But you're going to hear about that tomorrow, so we probably won't talk about that unless you have questions. So I'm going to use about half the time, about 20 minutes, going quickly through these slides, and then we'll open it up for questions and comments from you. Can you have the lights? So just to get us started, climate change is going to have severe impacts in the Arctic. That's why we have the polar bear there on disappearing sea ice. We have little girls at the beachside because, first of all, it's their generation and the children that follow them that'll be most impacted rather than we. And the ocean will be coming up. Just holding the rock in place is hard, and rolling the rock uphill is going to be really hard. And that's what we have to do. And on a local topic, this is a coal train coming down the Columbia. Maybe we'll talk about coal trains and Keystone if you have questions about that. Not primarily about policy. You're teachers, and you'll be talking mainly about climate science with your children. But parents who may come to you and say, why are you talking to my kid about climate change? You know, I don't believe in that. Well, say, well, you're welcome to your own belief, but not to your own facts. I'm teaching the science, okay? You're welcome to your own religion, your own personal beliefs, but not to your own facts. Teach the science, not the controversy. Teach the science. Okay, here we go. I put this in here because I want a natural world where this is still possible. I was in Brazil last October on a boat on a river, and this beautiful creature came down to drink. And he stood there for this is no fancy camera. This is a little nothing, right? I'm about 30 feet away. He's sort of saying, come on, come a little closer, come on. Beautiful cat in the afternoon light. I hope there'll always be a world where there'll be such creatures. This is my granddaughter, Hazel. I don't want her ever to say this. Granddad, you knew back then. Why didn't you do more to keep us safe and protect our world? So the greenhouse effect, you understand this already. And we'll talk a little bit perhaps about demonstrations, demos and exercises you can do in your classroom to demonstrate the greenhouse effect. Convince your students that no, oxygen is not a greenhouse gas. No, nitrogen is not a greenhouse gas. Yes, CO2 is a greenhouse gas. Yes, methane is a greenhouse gas. Yes, water vapor is a potent greenhouse gas. You can show that in a demo in your class. Here's the take-home message. You have an uncle, brother, cousin, somebody who's a climate skeptic. We all do. I've got a brother in Houston who's a chemical engineer. Hard to talk to him about climate change. This is the elevator talk, your 2-minute talk. 5 points. 1, climate change is real. It's happening right now. We humans are causing most of the change. 3, scientists agree on points 1 and 2. Scientists are not debating whether greenhouse warming is happening and is caused by human activity. They are not. They haven't been for a decade. Maybe your local weatherman is. Maybe your uncle doubts it. Maybe the politicians on one side or the other, mainly on one side, are doubting it. But the scientists are not doubting it. Every study that's looked at the published literature, science, nature, climate change, journal of geophysical research, look at the abstracts. Count them up. 12,000 abstracts. 97% of those say climate change is happening and humans are causing it. So we know more about this than we knew about smoking and cancer, okay? We know far more than we need to be acting as a society. 4, the impacts are going to be really bad. If we just continue where we're going, we're going to end up where we're headed. And it's a really bad world. The impacts are bad for people and for the natural world. 5, there's hope. If to avoid the worst, we can't stop climate change. We can't avoid climate change. It's already happening. But we can stop it from getting much worse if we act now. How much time do we have? Just enough time if we start right now. 97% of the climate papers stating a position on human-caused climate global warming agree. So when your uncle says, well, you know, I heard on Fox News or I read in the Wall Street Journal editorial that the scientists are still arguing, it's a lie. And you can tell your students that. And when the parents come and say, why are you talking to my kid about climate change? Say, that's the science. That's where the science is. What happened this summer? Last September, we set a new record for the minimum Arctic sea ice. The red line is the historical perimeter of sea ice at the season, September, for the minimum sea ice. And the white shows where the sea ice was last September. You can sail from Europe to Asia across the Canadian archipelago or around the Russian side. The Arctic is open for business, and the shippers in Europe know that. And countries of the world are racing for resources in the Arctic now. If you're a native person of the north, or a polar bear, or a narwhal, it's bad, very bad. So the sea ice itself, that was just the aerial extent, looking down, that would be area. But the thickness has also gone down. So if you multiply the loss in the thickness times the loss in the area, we're down to 1/4 of the natural sea ice over the last generation. Furthermore, one day last July, just about a year ago, on July 8th, the white area showed unmelted dry snow on the top of Greenland. On July 12th, the entire surface of the Greenland ice cap melted. Does it ever happen naturally? Yeah, every couple hundred years and irregularly, back to the ice core records, this does happen. Now this is going to happen almost every summer. What does that mean? That's the end of dry snow in the northern hemisphere. This is the last place where even in summer there was dry snow. Does that mean that the sea level is going to come up faster? Maybe, maybe. What happens if the whole Greenland ice cap melts? 6 meters, sea level rise, 20 feet. We'll be underwater right here. This is the rate of temperature increase in the Arctic, and it's going about 6 degrees C per century. So we talk about double CO2, maybe that'll give us 3 degrees of warming, 2 degrees of warming, but you can double or triple that for the high latitudes, especially for the Arctic. And this kind of a warming of more than 3 or 4 degrees, guarantees that we lose Greenland. Not in your lifetime, maybe not in the lifetime of your children, but puts it on a path to the 6 or 7 meter sea level rise in the coming generations, within 100 or 200 years. What does that mean, sea level rise? Well, again, I have a brother who lives in Houston. New Orleans will be gone. The southern part of Florida will be gone. And even here, we'll have dramatic changes. Here's what Florida looks like with a 6 meter sea level rise. There's no more Miami. There's no more New Orleans. There's no more Houston. And a lot of places on the East Coast are gone. And here in Seattle, this is a smaller sea level rise. This is only about, 5.5 feet or so. We lose a lot of the industrial area downtown. We lose Boeing Field, et cetera, and other areas. I don't have a map to show what would happen for us right here. This is where we are. But all of this is very low land. I mean, 20 feet of sea level rise puts all of this underwater, right? And good part of Olympia as well. Cartoons help in a grim subject. After a comprehensive review of the climate science, we've concluded that climate change is only 99.5% certain, not 100%, as previously stated. I knew it. It follows it's all a hoax. We know a lot about climate change and the human causation of climate change, enough to be acting. So don't let uncertainty be an argument for not taking policy action. Here's the famous Mauna Loa carbon dioxide record. Notice it's bending up. That means acceleration of the burning of fossil fuels. If we actually began to burn lower, the curve would start to bend over the other way. Is it going to go down? No, not for hundreds of years, maybe not 1,000 years. The only way we can go down is if we not only stop burning fossil fuel, but actively start taking CO2 back out of the air. That's hard and expensive. I was actually in charge of this network for the US government in the early 1980s when Dave Keeling was still alive. He started the record in 1958. And my job was to go to the mountain with Dave and say, Dave, you're going to die. You're mortal. You've made a beautiful record. This needs to be institutionalized by the US government. We need to be making this measurement side by side with you forever. And so let's do this. Let's cooperate on Mauna Loa, on the observatory, and keep this going. And that's still true today. Every minute, side by side, the Scripps machine and the US government machine by NOAA are taking data. NOAA also runs, we have minute data from 1960 or so from Barrow, Alaska, American Samoa, and the South Pole. So we're monitoring CO2 around the world. This Hawaii record is actually pretty representative of the global average. So when last month we hit 400 ppm, that was passing a very important milestone. The last time the world was at 400 ppm was 3 million years ago, before the cycle of the ice ages, long before humans existed. And the climate back then was several degrees warmer, and the ocean was not 20 or 30 feet higher, it was 100 feet higher, okay? So this is what we're building into the atmosphere. The climate hasn't quite caught up with the changes that we've made, but we know that we're forcing the climate in that direction. Another important thing is that back then, the CO2 was about 340. Now it's 400. That's 60 ppm different, parts per million, right? That's the concentration units. Another 60 ppm, going 340 back, takes you to 280. That's the pre-industrial natural level seen in every interglacial for the last 800,000 years. So the natural level is 280 during warm periods like now, and from 280 to 340, when I started making the measurements there, and then from 340 on to 400. So half of all the CO2 that's ever been put in the air has been put in the air since 1982. And how much can we put into the air? How much is left? I'm going to fill this glass half full with iced tea. Easier to see than water. And yeah, the glass is half full or half empty. But in terms of the atmosphere, the climate scientists say now, we've put into the air about half of the total amount of CO2 that we can put in the air and have any kind of reasonable world in the future. If we want a civilization and a natural world like the one that we grew up in, evolved in, we want that for our children, we're halfway there. That's 500 gigatons. A gigaton is 1 billion tons of carbon. 1,000 gigatons, that's it. Any more than that, you're over the top of the glass, okay? What is that? How did they come up with that number? The number is to stay below 2 degrees centigrade warming, which the whole world in international meetings has said that's the goal. That's the guardrail. Stay under 2 degrees of warming. The goal of the Framework Convention on Climate Change, passed in 1988, is to prevent dangerous man-made interference with the climate system. And the world community has said 2 degrees warming, that's it. We've got to stay under 2 degrees. If you want to stay under 2 degrees, you can't burn more than another 500 gigatons of carbon. We're halfway there. We're halfway there. As Sheikh Amani, who was former head of OPEC, said, we didn't leave the Stone Age because we ran out of stones. And we're not going to leave the fossil fuel era because we run out of fossil fuel. Long before we burned all the oil, long before we burned all the natural gas, and way long before we burned all the coal, we got to stop. If you're going to burn it, you got to capture it and put it back underground. It's underground for a reason. It needs to be underground. It's safely underground. In the air, it's dangerous. So this is too busy, but just look on the left-hand side and the right-hand side. Over here, coal, natural gas, oil. That's almost all of the sources of greenhouse gases. And these are all the sectors that use it. And over here, you can see the result. Carbon dioxide, 76% of the greenhouse gas forcing is CO2. It's a CO2 problem. Yes, there's some methane, it's a problem, and fracking makes that problem worse. Agricultural emissions of methane is part of it. Nitrous oxide, small, again, from agriculture, from ammonium nitrate fertilizers. And the hydrofluorocarbons and perfluorocarbons, which Obama and the head of China recently negotiated an agreement on to reduce the HFCs. But it's really a CO2 problem. It really is. It has been, and it will be in the future, a carbon dioxide problem. This is 400,000 years of ice core data from the South Pole. Why not from Greenland? Because 100,000 years, Greenland melted almost to bedrock. You can only go back one ice age cycle in Greenland. Ice age cycle is 100,000 years. So this is 400,000 years from Antarctica, and now we have 800,000 years of ice from Antarctica, all the way almost to the bottom of the Antarctic ice sheet. The CO2 and the methane are direct measurements, no assumptions. You just bring up the ice, crack it open, get the air bubbles that are trapped inside there, measure the CO2 or methane in the air, and you have a direct record of what the CO2 was present interglacial, ice age times, previous interglacial, ice age, interglacial, ice age, interglacial, ice age, etc. So we know how CO2 and methane have varied through cycles. The temperature can't be recovered directly. It's through using isotopes, hydrogen and oxygen 18 of the snow that was falling. You can recover the temperature. And you can see how they line up. Do the methane and CO2 explain the temperature differences? About half of it. Ice albedo feedback is the other half. And then on a different scale, that's 400,000 years, on a different scale, the last century shows temperature is just starting to turn up a little bit. Methane is actually triple the natural level. And CO2 on this old slide goes to 377. As I told you, we just broke through the record at 400 last month, 400 ppm. So we know geologically how CO2, temperature, and greenhouse gases vary. This is 2012. That's a map of the global temperature anomaly, departures from climatology. And notice that some places were really hot. This was actually the warmest year ever for the United States, ever in our history. It's the warmest year. It was also a horrible drought. More than 2/3 of the country was in some stage of drought all last year. And below this is the historical temperature record. Thermometers were accurate enough and widely spaced enough from 1880 that we can make the record. And after about 1970 or 75, there is no combination of any natural source that can explain the warming. Not volcanoes, not El Nino, nothing else. Not solar variability, only man-made greenhouse gases. The only way to explain this is that way. And so, yes, 1998 was a very warm year. And some climate skeptics say, there's no warming since 1998. We're cooling. Global warming must be wrong. Well, actually, 1998 was not the warmest year. In at least two of these three ways, the NASA, NOAA, UK Met Office, 1998 was superseded by 2005, warmer, and 2010 was warmer than that. So this decade of the 2000s was warmer than the 1990s. The 1990s was warmer than the 1980s. The 1980s was warmer than the 1970s. We're going up. Nobody said it's going to be a smooth ride every year. The variability is still in there. Things still happen. But we're still warming. It's true the warming over the last 10 years is a little slower than the previous 10 years. Why? A lot of the heat's going into the ocean, more than it had been. This is a 10-year picture of the warming for the decade of the 2000s. And several things to notice. Where are the red colors? The red colors are at the poles. The poles warm up more than the equator. Why? That's called isobeta feedback. You've seen this. A black pavement on a snowy day, scratch a little hole in the pavement, a little bit of asphalt is showing, and there's snow and ice all around it. And sunny day, and it's below freezing. You come back an hour later, that black patch is expanded, even though it's still below freezing. Absorbs more heat, melts more, absorbs more heat, melts more. That's what happens when snow and ice retreat at high latitude, revealing dark dirt, rock, or blue ocean. Accelerates the warming. It's a powerful, powerful feedback. That's why the poles warm up more than the mid-latitudes. Land warms up more than the ocean. Why? It's easier to warm up dirt than it is to warm up water. Different heat capacity. You can't see it in this picture, but the warming is greater in the winter than in the summer. The warming is greater at night than during the day. None of those things could be explained if it was solar variability. It wouldn't work that way. And the pattern of warming in the atmosphere would also be different if the sun was. We know the sun is not responsible. We have direct measurements of the sun. The sun is 99.9% constant. We're way outside solar variability. Very worrisome to see all that warming on Greenland. 20 years ago when I gave public talks, I would say to students and teachers, no, the polar ice caps are not melting. The sea level is rising because thermal expansion of the water itself and some snow and ice contributions. But now we can say yes, both Greenland and Antarctica are melting and contributing to sea level rise. About 1/3 of the current sea level rise is due to polar ice cap melting. If we lose the West Antarctic ice sheet, this is the Antarctic Peninsula. If we lose the West Antarctic ice sheet, that's another 5 meters. If you lose both West Antarctic ice sheet and Greenland, then you're at about 12 meters, about 30 or 40 feet of sea level rise. And that happened, actually, when the Earth was just a few degrees warmer than it is now. This is a busy slide, but I want to take just a minute to convince you of its importance. This is Jim Hansen's data looking at the Northern Hemisphere land summer data, temperature anomalies. So this sort of looking at the unusual, say that there's a black curve in here. It's a bell-shaped curve, sort of, random probability, bell-shaped curve, some hot days, some cold days with a certain envelope of uncertainty or variability. And that was true in the 50s and the 60s and the 70s. But look at the 80s, and then look at the 90s, and look at the present decade. Something's happening. The pattern is moving. The pattern is moving to hotter temperatures and getting more variable. So the basic state of the climate for the Northern Hemisphere summer is changing. And the same is true in the atmosphere, where we have 4% more water vapor than we did. So when we say storms are more fierce now, or rainfall is harder, yes, because there's more moisture in the air. The energy of the air is from the water that's evaporated. And that's up 4%. We measured it. Exactly what you expect, 4% per degree C. And we warmed up about 1 degree C so far. How about drought? Well, in the previous decade, there was some drought across the United States. And looking out some decades into the future, this Dr. Dye from NCAR, great name, Dr. Dye, predicts that the drought will get worse and worse and worse. And Susan Solomon, who was at the National Center for Atmospheric Research, I think she's at MIT now, she said, this drought in the center of the United States will be irreversible on human timescales. So if you say, well, you know, those guys in West Texas, they're running out of water, they can't grow stuff anymore. What if it's not a drought? What if a drought goes on for 10, 20, 30, 50, 100 years? And then the water doesn't come back for 1,000 years. You call it a desert. That's why it's irreversible on human timescales. It's not inevitable. We don't have to let that happen. But once it happens, it's irreversible. So think about that when you look at drought maps. And then going all the way out to 2090, you can see that the entire Mediterranean region would be in severe drought, as well as the center of the United States. And for places in Africa, each 1 degree of warming is 10 or 15% loss in grain productivity. So if they have 3 or 4 degrees of warming, they lose half their ability to produce grain. Here's the most recent drought map, getting a little better for some places closer to the Mississippi, but persistent drought in the west. My niece lives in Colorado Springs. They have had to evacuate their house, took their cat and their daughter and drove away. Didn't know if they would have their home when they came back. They were in Monument, so they didn't lose their house, but very scary, the drought conditions in the western United States. This was a beautiful tree for 450 years, Crater Lake. This tree died just 4 or 5 years ago. Beetle kill. Why are the beetles worse? Well, hot, dry summers, mild winters, they don't kill. They have 2 families instead of 1 each year, and they're chomping their way through the western forest. This is the figure from the Seattle Times of where beetle kill has occurred in the eastern Cascades and where it will occur. If you drive over Stevens Pass and look carefully, you'll see a lot of that rust-colored forest. That's beetle kill, and those forests are set to burn. So this is not Greenpeace or Earth First. This is the World Bank talking here. If we have any hope of keeping climate change below 2 degrees C, the peak year of carbon emissions has to be 2016. Wow, that's only 3 years away. You think the world is going to stop growing in CO2 emissions in the next 3 years and start down? We've started down. The U.S. is actually going down. Europe's going down. China and India are going up. And they can say, don't tell us not to burn carbon. You burned carbon, got rich. Don't tell us we can't burn carbon. And then there are people who say it's not happening. Climate denialists. Humans don't cause climate change. I like this one. Global warming is false, but I'm also a cat. Then there was this guy at Berkeley, Professor Mueller, a smart physicist at Berkeley, who was taking money from the Koch brothers. We're funding a lot of climate misinformation. You'll come across that name. And he said, I don't believe NOAA, NASA data, UK data. I'm going to make my own compilation of global weather, of climate for the last century or so. And he does. And he even goes further back than NOAA and NASA UK do. But they agree very well. And so he says, call me a converted skeptic. I have concluded that global warming is real and that the prior estimates of the rate of warming are correct. I'll even go a step further. Humans are almost entirely the cause of the warming. So he probably lost his money from the Koch brothers, but we're glad to have him on the right side of science. But if I turn up the heat slowly, then I don't notice that I'm in here with you, frog. Here's what's coming, and our prediction is not so different than the global prediction, a little bit higher than the global average because we're on land at northern latitude. We're going to get some, depending upon, climate prediction is difficult, especially about the future. And part of this uncertainty is because we don't know what the world economy is going to do. And part of it is what we don't understand about the Earth system in a climate model sense, the physics of it. But somewhere between 4 and 11 degrees Fahrenheit is what's coming in the lifetime of children born today. I sure hope we're down here. This is the 2 degree limit. I hope we're down here. I hope we're not up there. Now, this is the latest report from the Intergovernmental Panel on Climate Change. As she said, I helped write the carbon cycle chapter of the first report back in 1990, so I've been at this for a long time. Warming of the climate system is unequivocal. You can't equivocate it. It's unequivocal, okay? So when your skeptical parents come to you and say, yeah, you shouldn't talk to my kid about climate change, this is the data. This is the conservative opinion of all the climate scientists in the world. Unequivocal, okay? And evident from observations of increases in global average air and ocean temperature, widespread melting of snow, sea ice. This is from 2007, based upon science which stopped in 2005. We have 8 more years of science after that. The next report is due out next year, so look for that, IPCC 2013. IPCC finds that it is, quote, very likely 90 to 95% confidence. They're putting numbers on this. We're over here. This is a probability chart. We're over here, 90 to 95% confidence. This is in 2007, based upon data up to 2006. Very likely that the emissions of heat-trapping gases from human activities have caused, note the words, most of the observed increase in global. It doesn't say, well, we don't really know. Maybe people have something to do with it. No, most of the warming. That means more than half. Most of the warming is due to human activity. That's a conservative scientific opinion as of 7 years ago. Obama has said some good words. I'm still waiting for some action. He gets credit for fuel efficiency standards for vehicles. We want to see the EPA put emission standards on current coal-fired power plants and future coal-fired power plants. There's lots to do. Of course, I'd love to see him sign a global treaty and get it through the Senate. I don't think that's going to happen. U.S. National Academy, again, these changes are in large part caused by human activity. So there's nothing new here. And the same statement would be made by any of the national academies of science in any of the countries of the world, okay? So what a conspiracy it is, those guys who's denying that it's happening. I showed this in Issaquah at an old folks' home, like retired professors, and one old guy said, dang, I hope I live to 2012. But how sensitive is the climate? We don't know. If we double CO2, are we going to get 2 degrees of warming or less? Very unlikely. We're going to get 3 or 3.5 degrees of warming centigrade, double it for Fahrenheit. Or look at that long tail. We might get 6 degrees if we double CO2. Double means you go from 280 to 560. We're already at 400. We're well on the way, okay? That's just CO2. You've got to throw in another 20% for the methane, nitrous oxide, ozone, et cetera. So we don't know. This is a big unknown. What is the climate sensitivity? The equilibrium temperature after we double CO2 and let the world run to equilibrium, which takes a long time because of ocean mixing. Here's the northern hemisphere temperature for the last 1,000 years. The famous hockey stick, which again, denialists say has been rejected. It's not been rejected. It's been supported and reconfirmed by many, many other studies. And notice the scale. Over the last 1,000 years, and you can run this back another 1,000 years to the time of Jesus, looks the same. For the last 1,000 or 2,000 years, the global temperature has not varied by more than half a degree C, 1 degree Fahrenheit. And now we're up here. Now we're off scale. So we're in a climate that the world has not experienced for at least 2,000 years by direct measurement. These numbers are reconstructed from tree rings, boreholes, lake sediments, et cetera. There's no temperature. The red is the historical temperature record that I showed you before. And then very recently, a paper has reconstructed the temperature for the last 10,000 years. Surface temperature for the last 10,000 years, again, from proxy data. And the temperature now is as high as it's been, with a few exceptions, for the last 10,000 years. That's the entire period, warm period, since we came out of the last ice age. It's called the Holocene. There was a Holocene climate optimum maybe 8,000 years ago. There was a few times back then when it was as warm as it is now. And here's where we're going if we have 8 degrees. So we're on track for something really unprecedented. Not just the magnitude of the warming, but the rate at which the warming will occur will be very hard for us and for the natural world. Here's the guardrail, the 2-degree guardrail. This is the burning embers diagram. This is a 2001 sort of view of bad things that might happen. Rising fossil fuel energy use will lead to irreversible and potentially catastrophic climate change. Again, catastrophic. Fox News doesn't like us to use words like catastrophic. This is the International Energy Agency, the World Bank. And here's what's going to happen unless we change. 2 degrees of warming. I hope we can stop there. But you can see that, yeah, that's right. For a couple degrees of warming, maybe we'll get better crop yields in northern Canada and some places in Siberia. But if we keep on warming, it's going to be a loss of agricultural productivity everywhere in the world, especially in Africa. Water, we're already losing small mountain glaciers, even at 1 or 2 degrees, and drought in Mediterranean region and southern Africa. And then above 3 or 4 degrees, then we're really talking about Greenland and Antarctica and a major sea level rise threatening all the major coastal cities of the world. One way to think of it is that every meter of sea level rise is 50 to 100 million people. You get 6 meters of sea level rise, 600 million people displaced by sea level rise. Where are they going to go? They lose their agricultural deltas. They're going to be moving back from the rising sea. We're already losing coral reefs. By some estimates, we've already lost a quarter of the coral reefs in the world, and we'll lose even more. And if we go to 3 or 4 or 5 degrees, we could have an extinction event that rivals the asteroid that killed the dinosaurs, when 2/3 of all the species in the world went extinct. That would be bad to have on our record. We shouldn't let that happen. My granddaughter would not like that. Rising intensity of storms, forest fires, droughts, floodings, heat waves, that's already happening. Most people don't realize it. Did you know that 60,000 people died in Europe in the summer of 2003? 60,000 people. If we had a heat wave in the US that killed 60,000 people, we might be radicalized. And then a few years later, in 2010, 50,000 Russians died in an unprecedented heat wave in Russia. We haven't had those kind of events here. Maybe that would change us. I'm not asking for it, but we certainly need a wake-up call. And then there's what former Secretary of Defense Donald Rumsfeld talked about, the known knowns, the known unknowns, and the unknown unknowns. Well, down here with the unknown unknowns is loss of methane from melting permafrost, stopping of the Gulf Stream. Those things are out there. They're not in the climate models. Those are some of the unknown unknowns. What does John Holdren say our choices are? Well, our choices are these: mitigation, avoiding the change to which we cannot adapt. I think a 5 degrees centigrade, 10 degree Fahrenheit world is a world to which we cannot adapt. That's the end of human civilization as we have known it. We must not let that happen. So mitigate it. Reduce the emissions so that doesn't happen. Adaptation, adapting to the change which we can no longer avoid. We need to be adapting now. Mayor Bloomberg's talking about how New York can adapt to climate change and sea level rise after Hurricane Sandy. And then harm, minimizing the human suffering and the damage to the natural world. And then the important question is, who benefits from burning fossil fuel and who suffers? Who benefits and who suffers? So this is a real ethical, moral issue for our generation, for the world. So just like my glass of tea, imagine that it has no leak, it doesn't have a leak, and imagine there's no evaporation. So unless I'm drinking it, if I add more tea, the level goes up. Now, the level can go up slowly, or the level can go up fast. But what matters is how much tea is in the glass. What matters is how much carbon is in the air, not the rate we put it in. It almost doesn't matter. China can put it in, we can put it in, you can put it in slow, you can put it in fast. What matters is how high the CO2 is, okay? That's what matters. And so that's what's in these figures. And you can make some nice exercises for students around this concept. If you want to stabilize the concentration, which is how we're going to stabilize the climate, then you need to stop the emissions, 80%. Stop burning coal, oil, natural gas, or if you're going to burn it, capture the CO2 and put it back underground where it can't come out for thousands of years. If you burn it, it's free, right? Doesn't cost anything to put CO2 up, and yet we need a carbon tax. If you want to stabilize the concentration, the only way is to reduce the emissions. If you say, well, let's just level off the emissions, have the world just stay at constant, well, that does nothing. That just has you going on up at a constant rate. Right now, we're increasing emissions, so the increasing concentrations. So those are the facts. If you want to stabilize the climate, you have to cut emissions a lot. 50%, 80% by 2050, even while China and India are still using a lot of coal and oil. We need to get off of fossil fuels now. That's why I'm against all major investment in anything to do with new fossil fuels, whether it's Keystone, coal exports. Don't do it. Don't invest in that. Now, you probably couldn't tell your students that. That's a policy question. And it's a value question. I take off my science hat. I'm telling you as a father, a husband, as a person. That's what I think. Okay, so we're already starting down, but here's where we have to go. 80% down by 2050. And here's the U.S. Energy Agency saying that's what they think we're going to do. And under Copenhagen, we said we're going to get here. So we got a long way to go. Yeah, it was great that we have fracking, if we're careful about it and don't mess up the water and don't have fugitive methane emissions, all those ifs. It lets us shut down coal-fired power plants, which is good. That's half the emissions, reduced by half to go from coal to natural gas. Fuel efficiency for cars, that's good. We have a long way to go. There's a lot to do, but those are good things. Again, no more than 1/3 of the proven reserves of fossil fuel can be consumed prior to 2050 if the goal is to stay under 2 degrees. Again, that's the International Energy Agency, not Greenpeace or Earth First. 2/3 of it's got to be left in the ground. So you think ExxonMobil and Shell Oil, they've got a lot of money in the bank, and look at their reserves, boy. Those are stranded assets. They will never be able to dig it up, sell it, and burn it. So it's worthless. Don't invest in fossil fuels. In fact, divest from fossil fuels. So I'm almost done. I know I've gone on too long. Global warming isn't happening. It is happening. Well, if it's happening, it's a good thing. It's not a good thing. If it's not a good thing, it can't be confirmed. It has been confirmed. If it's confirmed, maybe it's not caused by humans. It is caused by humans. And even if it's caused by humans, maybe it'll fix itself. It won't fix itself. And if it won't fix itself, there's nothing we can do. There are things we can do. And if there are things we can do, they're too expensive. They're not too expensive. And if they're not too expensive, we can postpone doing them. We can't postpone doing them. Hey, what do you mean? This conversation has been going on for over a decade, and I'm just warming up. This is a cartoon from 2005. So as long as we have this kind of conversation, we're not doing what we need to be doing. We're going to end up where we're headed unless we change directions. And I like this cartoon too. Oh, I like Abraham Lincoln's quote, "Let the people know the facts and the country will be safe." As teachers, you can relate to that. So here's a guy up here talking about energy independence, rainforests, green jobs, livable cities, renewable, clean water, healthy children, blah, blah, blah. Hey, what if it's all a big hoax and we create a better world for nothing? The ultimate test of a moral society is the kind of world it leaves to its children. And then I like this quote from the Earth Charter. "Let ours be a time remembered for the awakening of a new reference for life, the firm resolve to achieve sustainability, the quickening of the struggle for justice and peace, and the joyful celebration of life." Thank you.